Ayubowan, welcome you all. This is the last part of this final examination paper discussion in Basic Principles of Chemistry 2. So, I am going to discuss the kinetic question of paper final exam 2019-20 paper. Okay. In first question, they ask, what do you understand by the following used in the study of kinetics? චාලක රසායනයේ පහත දැක්කනේ වගේ මොනවද කියවෙන්නේ? Rate determining step. What is rate determining step? You have to define. And under what conditions the elementary reaction A plus B give product could be made a pseudo first order reaction. These two things we have to explain. However, at the initially I have to say, you have to know these terms. Rate determining, what is reaction mechanism? Last year they asked, in this question they asked rate determining step. In this year there is a great probability to come reaction mechanism, the rate of a reaction, and elementary reaction and molecularity of a reaction. You have to know the definition of these terms. Okay. Session number 2.5. Go through that. And what is, if they ask what is reaction mechanism, what is the answer? The sequence of events leading to the final product is known as the reaction mechanism. The rate determining step, we have to know, if we consider multiple reaction, that means here first of all I will give the rate determining step. You know there are some reactions, they will give products by series of steps. There are so many steps, after that they will give the final product. So to achieve this final product we have to pass so many steps, more than one steps. So this type of reactions we call complex reactions. Complex reactions. So the slowest step of this reaction complex will determine the rate of the overall reaction. ඔයාලා දන්නවා සංකීර්ණ ප්‍රතික්‍රියාවක් ගත්තොත් එහෙම ඒකේ එක පියවරකට වඩා පියවර තියෙනවා. There are so many reactions. නේද? ප්‍රතික්‍රියා ගණනාවක එකතුවක් තමයි සංකීර්ණ ප්‍රතික්‍රියාවක් කියන්නේ. එතකොට අනිත් අතට reaction mechanism එකක් කියන්නේ මොකද? ප්‍රතික්‍රියා යාන්ත්‍රණයක් කියන්නේ යම්කිසි නිශ්චිත අවසාන ඵලයක් ලබා දීම සඳහා සිදුවන ප්‍රතික්‍රියා දාමයක එකතුවකට තමයි කියන්නේ අපි reaction mechanism එක නැත්නම් ප්‍රතික්‍රියා යාන්ත්‍රණයක් කියලා. ඉතින් ওই දෙකේම complex reaction or reaction mechanism there is a slowest step. හෙමින්ම සිදුවෙන ප්‍රතික්‍රියාවක් තියෙනවා. That slowest step will determine the rate of overall reaction. So that is known as, that slowest step known as rate determining step. The common example, imagine group of friends go a trip. Imagine that a hike, you go to climb the Hantana mountain. No, there is a person who can't walk very fast, so what will happen? He will walk very slowly. So others have to go the rate of that person. නේද? එතකොට හිමීට යන කෙනා ඉන්නවා. මොකක් හරි ගමනක් යනකොට හිමින්ම යන කෙනෙක් ඉන්නවා. යාළුවෝ සෙට් එකක් ගමනක් යනවා. එක්කෙනෙක් හරිම slow. ඉතින් අනිත් අයට අර යාළුවාව කරේ තියාගෙන යන්න බෑනේ. Others have to follow that slowest person නේ. ඒ හිමීට යන කෙනා අනුව යන්න ඕනේ. So slowest step will determine the rate of overall reaction. අර ට්‍රිප් එකේ සම්පූර්ණ ගමනට ගත වෙන කාලය සහ ඔක්කොගේම වේගය රඳා පවතිනවා අඩුවෙන්ම හිමින් යන කෙනා මත. So that is the rate determining step. That's the answer for first one. Go through the book and notes. Rate determining step. Here that is the definition. The strength slowest step when considering multi-step reactions. That's the smallest, or that's the good answer. Slowest step of a multi-step reaction. බහුපියවර ප්‍රතික්‍රියාවක හැමින්ම සිදුවෙන ප්‍රතික්‍රියාව තමයි වේග නිර්ණය පියවර කියලා සිංහලෙන් නම් එහෙමයි. Slowest step of a multi-step reaction, that is the definition of rate determining step. Okay, that's first one. Second question they ask, under what conditions the elementary reaction A plus B, elementary reaction they given A plus B will give products. This is an elementary reaction. Elementary කියන්නේ මොකද්ද? මූලික ප්‍රතික්‍රියාව. When we heard this elementary term, we have to, one thing you have to come into your mind. What is that? When it is elementary reaction, the order of the overall reaction is equal to the sum of the order of individuals on the in other words, in elementary reaction, the stoichiometry of these reactants will give the order. So order of A will be 1 according to this reaction, order of B will be 1 because the stoichiometry is 1. In elementary reactions, the stoichiometry of particular reactant is equal to the order of that reactant. මොකක් හරි මූලික ප්‍රතික්‍රියාවක් කියලා දීලා තියෙනවා නම් මූලික ප්‍රතික්‍රියාවක ඒ ප්‍රතික්‍රියාවේ එයාගේ ස්ටොයිකියෝමෙට්‍රි එක තියෙනවානේ. ස්ටොයිකියෝමෙට්‍රි එක ඒ අදාළ කෙනාගේ ඕඩර් එකට සමාන වෙනවා. හැබැයි it should be elementary reaction. පේපරේ දීලා තියෙනවා elementary reaction එකක් කියලා. Okay. So here they mention elementary reaction, this reaction. So under what conditions the elementary reaction could be made a pseudo first order? ව්‍යාජ පළපුපලක් වෙන්න මොන අවස්ථාවේදීද? Under what conditions this will we convert into pseudo first order? So in previous question I discussed that thing. Compared to one reactant, other should have considerably higher concentration. So if we consider A, its concentration must be very higher than B, or concentration of B should be very higher than A. Under these two conditions, reaction will be pseudo first order with when we compare with other one. If we consider this part, 1, A will be higher than B. So the rate expression for this equation minus dA with respect to A rate is equal to K A into B. If the A, concentration of A is very large, we assume concentration of A is constant. We assume that. අපි උපකල්පනය කරනවා මෙයාගේ සාන්ද්‍රණය ගොඩක් වැඩි නම් මේ සාන්ද්‍රණය නියතයක් කියලා. ඒ අවස්ථාවට both K and A will give another constant K star which is known as pseudo rate constant. So equation will be minus dA divided by dt equal K star concentration of B in first case. This case, if we consider this case, what is that? Minus dA over dt K. Now concentration of B is very high. I will write B front and A after that for easiness of my calculations. Now B is very higher. I assume concentration of B is a constant. So D minus dA divided by dt is equal to K star concentration of A. This is pseudo rate constant with respect to this second situation. So we don't have to write down these expressions. They ask under what conditions the elementary reaction A plus B will give products could be made a pseudo first order. So we have to write down in words. We have to say if the concentration of A very higher, considerably very higher than B, or if the concentration of B is considerably very higher than A, that will give the pseudo first order reaction. That's the answer. If you have time, write down these equations also and you can explain very well. Okay, but you are dealing with time, please care about that. So second part, B part. Two A plus B will give products. 2A plus B will give product. They given that this is a hypothetical elementary reaction. Highlight that word, elementary. That means that is single step reaction. මූලික ප්‍රතික්‍රියාවක්. So stoichiometry of this reactant will represent the order of them. ඒක තමයි conclusion එකනේ. මූලික ප්‍රතික්‍රියාවක් කියලා දීලා තිබ්බ ගමන් අපේ ඔළුවට යන්න ඕන මොකද්ද? පෙළ A ට සාපේක්ෂව පෙළ 2 වෙන්න ඕනේ, B ට සාපේක්ෂව පෙළ 1 වෙන්න ඕනේ. මොකද යාළගේ stoichiometry එක පෙළට සමාන වෙනවා. Okay. Write down the rate expression for the above reaction using the standard symbols. By using standard symbols, we have to write down the rate expression. So, with respect to A, I will get A, rate will be minus dA divided by dt. However, in this situation we have to care about one thing. What is that? When we write down the rate, if the reaction is this A plus B equal product, we can write down just simply dA over dt equal K, concentration of A, concentration of B. But here the stoichiometry is 2. Now we can't write just dA over dt. Why? The rate with compared to A and rate with compared to B is somewhat different here, because their stoichiometry is different. So to get equal expression, we have to divide dA by its stoichiometry. So rate is equal K, concentration of A square, concentration of B. This is the rate expression. Instead of this, you can write down just simply dB dt is equal K A square B. Okay. Equal R. You can write down R is equal K A square B. All are same. Okay. All are correct. Okay. Next question. Determine the SI units of the rate constant K. So we have to determine the SI units, the units of K in SI units. In previous questions also I discussed this. So if we consider this equation, we have to get the unit. So I will get expression for K. K is equal minus dA, here dt, here A square will come to lower side B. Okay, I rearrange the equation. These are in multiply in this right side. When they come to left side, they will be divisions. Okay, now just forget these numerical values 1 and 2 and these negative signs. We have to apply the units of these terms. Here concentration term, initially we will add, we know the concentration term will be moles per cubic decimeter normally, but here we will consider in SI units cubic meters. So mol cubic meters divided by, here dt, SI units is time is seconds, and here square of concentration, so mole square and cubic per cubic meter square 6, and concentration of B mol cubic meters per cubic meter. So per cubic, this term mole per cubic meter will cancel out for this, and this part will goes up, so units of K will be, here mole to the power plus 2, when it goes up it will be negative, and this negative 6 will become positive 6, and this second will be per second. This is the units of K. There is another easy way, I told you, but it is not given in your book, so you can't write down that method. However, there is a method to calculate the units. So here we know this is elementary reaction, the stoichiometry will be their order, so the overall order will be here, the order respect to A is 2, order respect to B is 1, overall order will be 3. Okay, so common expression m1 minus n t minus 1 for calculate units. M in concentration term, so 1 minus n, n is order. So what is the order now? M1 minus order is 3, T minus 1. So here M concentration we apply. So here 1 minus 3 mean M will minus 2, T minus 1. So when we apply our equation, so units moles per cubic meter, power is negative 2, T minus 1 means seconds. So we can simplify this moles, outside the bracket there is minus 2, so it will be mole minus 2 power, and this minus 3 will multiply with minus 2, that will be positive, ne? So cubic meter will be 6, positive 6. So and seconds will remain as seconds per second. So same answer come from two things, so we can verify our answer. Okay, so this is the SI units. That's the second part, and third part I will erase. Third part, assuming that this reaction is carried out with an excess amount of B, excess amount of B relative to A. Now they are saying B is excess related to A. So B is very higher. Now we can assume if B is very higher, concentration of B will be constant, we assume. Because of this data, we can assume that. Okay, and derive an expression integrated form. We have to integrated form, derive integrated form for the pseudo rate constant. Pseudo rate constant K star of the reaction in terms of the concentration of A at time t, and its initial concentration is A0. Initial concentration of A will be A0 at time 0, at time t it will be A. And we have to get the pseudo rate constant at K star. Okay, now minus 1 over 2 dA over dt is equal k, b is now higher, a square, this will be pseudo rate constant, so minus half dA over dt equal k star a square. Okay. Now they ask derive an expression integrated form for the pseudo rate constant of the reaction in terms of concentration. So we have to integrate this equation. How can we integrate? We will put integral marks here, minus 1 over 2 dA over dt equal k star. Before integration we have to rearrange the equation. How? Concentration terms will come to left side and other terms should go to other side. So minus half dA a square equal k star dt. Okay, I will erase other parts. Okay, here minus half, I will put integral mark, integrate 1 over a square here dA equal k dt 0 to t. We have to input the limits here a naught to a. Okay. Now 1 over something, if we integrate 1 over a by dA, answer will be ln a. However, here a has a power, so we can't apply this integral rule. Instead of, we have to apply power rule of integration. What is that? If a to the power n, we integrate dA by dA, answer will be a n plus 1 divided by n plus 1. However, here a is below this 1 over a to the power 2. So we can't apply this. So we have to rearrange this term as a minus 2. It will go upper, minus 2 dA. I rearrange the equation here, minus half equal k dt 0 to t. Okay. Now I can apply this power rule. How? Minus half. So what about integration? After integration I will get a minus 2 plus 1 divided by minus 2 plus 1. Okay, limits a naught to a equal k here after integration t 0 to t. Okay. Okay, what will be the answer? Here minus half, minus 2 plus 1 will be a minus 1, here minus 1. Okay, here a naught a equal k. We simplify in this term t minus 0, that will be kt. Okay, here minus and here minus, we will multiply that, it will be positive. I will erase this term. Minus minus will be cancelled out, and here a to the power minus 1, I will rearrange the equation to get a to the power positive 1. So 1 over a naught to a equal k t. Okay. However, I will get simplified version. I will deduct lower limits by upper limits. Here half within brackets 1 over a, here concentrations, 1 over a minus lower limits 1 over o naught, 1 over a naught equal kt. So they are asking derive an expression for the pseudo rate constant of the reaction. So we need the expression for this. Here k star, every term pseudo rate constant, no? Pseudo rate constant. So k star equal within brackets 1 over a concentration minus 1 over a naught concentration divided by t, here 2. This is the expression for k star, pseudo rate constant. Okay, now they ask derive the expression for time t. When time t, initial time is 0, initial concentration we know a naught, at time t it will be a. Now they given this time, at time t 20% of a has reacted. At time t initial concentration is a naught, 20% will be reacted, 20% reacted now. So remaining part is A. So what is the A? If the reacted part is 20%, remaining part will be 80%. Okay. Calculate the corresponding time taken if the rate constant for the, now they given the rate constant also 4.0 into 10 to the power minus 5 per mole per decimeter per minute. This is the rate constant, and initial concentration A naught given. A naught is 1.0 mole per cubic decimeters. Everything is given. Now we know K, we know A. This is initial concentration. So what about the final concentration? After reacting 20%, remaining will be 80%. So after time t, A will be 80%, means 0.8 mole per cubic decimeters. This is the final concentration. So we know that A, we know K. So we have to . we have to derive the expression for t. From this equation we have to derive expression for t and we have to calculate the time. Okay, so if we use this common expression, initial expression, we can derive expression for time. So half 1 over a minus 1 over a naught divided by k equal t. This is the expression for time and we will calculate the time. Let's substitute. Half, actually okay, half here 1 over a will be 0.8 minus initial concentration is 1.0 and divide by k. Here k is 4.0 into 10 to the power minus 5 per mole cubic decimeters and minute. These are m concentrations. We have to apply units also. So what is the calculations? So answer for this within bracket portion will be 1 over 2, here 0.25 per mole cubic decimeter, here 4.00 into 10 to the power minus 5 per mole cubic decimeter per minute. Units will cancel out. So it will be if this power goes up, what will happen? 250 ne? In minutes. So let's calculate. Use the scientific calculator. That will be 3125 minutes. Recheck your answer. Yes, it's correct. In minutes. They are asking in calculate the corresponding time taken if the rate constant for the above. Okay, but it's better if we give this time by seconds, multiply by 60, sorry, 187,500 seconds. Okay, that's the end of this question. Okay, and in its part A part A of this question paper. They given us a rate equation of a reaction as Kt equal x divided by A minus x. This expression they given. So in T equals 0, initial concentration is A per mole per cubic decimeters, and after time t, seconds, they highlighted seconds, t concentration will be x moles per cubic decimeters. Okay, so they ask us to determine the half-life of this reaction. Half-life mean, what is the half-life? Half-life meaning when the initial concentration is going become its half, when if the initial concentration is A, when it is become A over 2, that means decreasing up to A divided by 2, half, the time taken is T half. ආරම්භක සාන්ද්‍රණය අර්ධයක් බවට පත් වීමට ගත වන කාලයට කියනවා අර්ධ ජීව කාලය, අර්ධායු කාලය. So just assume at T half, that half life given by T half, T subscript half. Okay, T half. So if we assume at T half, the final concentration is A divided by 2. Initial concentration is A, final concentration is A divided by 2 at T half. So here final concentration is X at time T. However, in half life, this expression I can write down as K T half. At T half, final concentration X will be A over 2. So instead of X, I will substitute A divided by 2 and A here, A minus X mean A over 2. So we can simplify this equation. Okay. So KT half is equal here A over 2, here A. So by simplifying this equation, you will get this expression, and by rearranging we can get 1 over A. Both will cancel out, and here KT half. So we need expression for T half. So T half is equal 1 over K. Here multiplication will be division in right side, K A. This is the expression for T half, and they given us the value of rate constant. K is equal 6.0 into 10 to the power minus 3 per mole per decimeter, cubic decimeter per minute. This is somewhat important. Why? Here in question they mention time in seconds. However, rate constant is in minutes. We have to take care about that unit conversion also. Okay. So they ask the time in seconds, but the rate constant is given by minutes. Keep that thing in your mind. Okay. However, let's calculate T half, and initial concentration they given A. They given A is 1 m. Okay. Now let's substitute this equation. T half is equal 1 over K is 6 into 10 to the power minus 3 per mole cubic decimeters per minute into A is concentration, that is 1 mole per cubic decimeters. So units will cancel out here, per cubic decimeter and cubic decimeter, per mole, and answer will come here. 10 to the power minus 3 will go up and divide by 6. You will get answer 166.6 minutes. However, they are asking in seconds. So multiply by 60, we will get seconds. Answer is 10,000 seconds. This is the answer. Okay. In its second part, question, they given an elementary reaction A plus 3B will give product 2C. Okay, in first question they ask, write down the rate equation in terms of minus dA over dt. In this term, by using this term we have to write down expression for rate. So dA over dt is equal concentration of A. We know this is an elementary reaction, they given that. If the elementary reaction, their stoichiometry is equal to their order. So order of A is 1, we will not write down 1, and B will, its stoichiometry is 3. This is the expression for this elementary reaction. Second, in third question, they ask what is the overall order of this reaction. So if this is an elementary reaction, overall order will be, order with respect to A is 1, order respect to B is 2, 3, overall order will be 4. Okay. Next question, they ask, write down the relationship between decomposition of A, here A is depleting or decreasing, B also decreasing, C will be forming. So decomposition of A, decomposition of B, and formation of C, we have to write down relationships. So they ask rate, in other words they ask expression for rate. So here A will be decreasing, dA over dt, it is decreasing, negative sign, and relationship, no, it is equal to dB over dt. If you write down this, you are wrong. Why? Stoichiometry is 3, it is not equal, so we have to divide by stoichiometry, and this is equal it is equal with respect to C. C is forming dC by dt. If you write down this, again you are wrong. By here stoichiometry is 2, we have to divide. If we don't divide, we can't apply this equal mark. 2, what is the sign? It is forming, so sign is positive. Okay, these are the relationship between, here also dB also decreasing, so dA minus dA over dt minus dB divided by 3 dt and equal 1 over 2 dC over t. These are the relationships. In next question they ask, there is an equation dA over dt. In question they are not given that this is negative, so we consider only their given expression dA over dt is equal k A naught. Here they mention that initial k A naught 2 and B naught, and they ask write down the log form of this expression. Log form, we have to apply log, just logarithms. Log 10 base dA over dt within brackets equal log 10 base here k plus, because this is multiply, we had plus in logarithms, log 10 base A naught square plus log 10 base B naught. We can simplify again, log 10 base dA over dt log 10 base k plus, here 2 is the power, we can get it to front, 2 log 10 base A naught plus log 10 base B naught. This is the logarithmic form. So that's the end of that question. Okay, go through these questions and good luck for your final examination. And this is the end of this discussion session. Okay, if you learned something this video, please leave a comment and please subscribe my channel and please share this video, and please stay with me because I will upload so many videos on your second year and third year also university level, and I will add in future I will add advanced level and ordinary level videos also, and general life videos. So please stay with me. I am Hasan Kalimgarachchi.